Okay. Hello, everyone. Good evening. Can you hear me? You want me to be louder? Okay. I'll start with a quick introduction about myself. I'm Amol Gaikwad. I have overall 14 years of hands-on experience in software engineering, where most of the majority of my career has been in building custom software solutions for complex business. Custom. I'm building custom software solutions for complex business problems, where oftenly most of them are related to building scalable distributed systems. So I wear different hats at times, like as a tech lead and an architect. But over the past years, I've started exploring a new area, which is the data engineering world, where I got an opportunity to work with two projects. Like I did a so in this one is typically about coming and designing and implementing the solutions for two clients. So out of that today, one is the one which I want to be talking about and sharing the learnings what I had as a part of this particular project. So just to understand, from the audience perspective, how many of you are here like new to the data engineering world, or probably I'll say that same path as mine. Okay. How many of you are already like working on data engineering projects? Cool. Okay. So I'll try to uh, probably come up with thoughts where I could, like come up what would have been the other alternatives or like the challenges that came to my when I was working on this project. What were the ideas that came to me? What were the alternatives for this particular problem? So that's something I'll try to come up. If you have any questions, feel free to stop me and like ask those questions to me. No need to wait for the last slide, which talks about questions. I mean, the statement itself, I feel like it's a lot of heavy, and I feel a lot of responsibility in explaining that. I would. Else, I would be drinking water for every 5 minutes. Is it better? I hope there's no echo. Okay. The title says like empowering data-driven decisions. Uh, what's the first thing that comes to your mind when I say that data-driven decisions? Anyone? Sorry? Graph? Okay. 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 So the response is what I got is like you would have something like a UI where you would see some graph. Yeah, the input that I got is like you would be deriving the decisions using some data. Okay. Just to explain further, like what do we mean by data-driven decision making and the importance of storing the data and analyzing it in a simple way. Let's take a simple example. So imagine you're running a particular cafe, right? And in that cafe, everyday customers come and buy coffee, pastries, and sandwiches. Now, if you rely on your instincts and your memory to understand what your customers like, you would probably say that, hey, coffee is the best thing in my cafe, right? Probably that's personally what you like. But it may be like in your cafe, the pastries are something that are famous, which you did not notice, right? So in that case, if you have to make better decisions, right? So let's first start collecting some data. You would want to track the sales that are happening in your cafe. You start noting down every day what are the numbers of pastries, sandwiches, coffee that is being sold every day. That's being sold every day. And you also would want to note that at what time of the day this particular sales happened, right? And you would want to store this particular information somewhere, probably a notebook or probably a computer, so that you don't eventually forget the details about it. Now, let's say after a month or so, you sit down and try to analyze the data. Once you analyze the data, the first things that come, or like the information that would come out of that, probably let's say that your pastries are something kind of famous in the morning. Your sandwiches are kind of popular during the lunch times. Your coffee is sold more when the days it's cold versus when the day it's hot. And probably your customers complain about your sandwiches more than your coffee, right? Now, based on these decisions, you could now, this information can help you to make your business better. Right? Probably you take some decisions like maybe have some promotion for your pastries in the morning. You would want to stock up more coffee when the days it's cold, right? And probably incorporate the customer's feedback for your sandwiches. Okay. That's something that's famous in the afternoon. So similarly, what happens is like companies do collect a huge amount of data uh, from different sources. Now, what do I mean by sources over here is like your customer transactions that are happening, website activities, social media feedback. And when they go ahead and analyze this particular information, they would want to get more insights and understand what their customers' preferences are. They would get inputs like how do you improve your existing products and services. You would also be able to predict the future trends that are happening in this particular industry or like the line. Also, you would be able to make better decisions where you would want to understand how to improve your sales, how do you cut cost, or probably you want to target a specific set of customers. So this particular information can help you take decisions in a very informed way, rather than you relying on your instinct or gut feelings, where you don't want to make some blind guesses. But these are more of informed decisions. So similarly, as we did for the cafe, using this data, companies are doing the same thing. So I guess as everyone now have a little bit of clarity about what do we mean by data-driven decisions, let's go ahead and take a look at one of the data engineering solutions that we as a Sahaj built for one of our clients that help them to take a reference of the insights and make better decisions. So before I start talking about the problem statement, I'll set a context about what this company is or the client is, in what particular domain they are, so that it's easier to understand like what problem they're trying to solve and like how did we come up with a solution for it. So Greenleaf Publishing Group is one of the leading global academic publisher that focuses on advancing discovery, learning, and research. So this is into a publishing domain. So they publish high impact scientific journal books and research across various disciplines. They are more into like providing access to millions of scientific and academic documents using the digital research platform so that researchers can discover it as well as share it among themselves, like increasing the knowledge among the community. They are more of an advocate of open access publishing. When I say open access publishing, which means that the scientific research that are available, they make it freely available to the global community across different disciplines. So it's free for viewers, but it would be kind of like a paid service or for the authors because they are trying to publish their uh, findings or their research, their philosophies over there. I don't know if philosophy is the right word, but yeah. Um, they're also into providing educational contents related to like textbooks, reference works, and professional resources to students, educators, and professionals so that they can use this information to improve their work. Along with that, they do provide data-driven insights and tools to the researchers as well as the institutions, which help them to improve the quality, the impact, and the visibility of their work. So this is at a high level the domain that Greenleaf Publishing Group is into. So before Sahaj came into picture, they had three submission systems, one called as Nexus, Accelerate, and Eclipse. The Nexus and Accelerate are something like a traditional or legacy systems what they had, and they had a new strategic system into picture called as Eclipse, where they wanted to uh, kind of divert all their new submissions to this system and eventually like kind of retire the old systems. When I say submissions, right, like let me set a context about what do I mean submissions over here. So I'll talk about these three terminologies over here so that we understand from a domain perspective. So these three terminologies in the context of publishing domains is like, what do I mean by an article? An article is a specific written piece of original research, findings, review of existing literature, or theoretical analysis. This is something what authors submit. They would go to this publishing websites and they would submit these things. Now they submit it in order to be published it as a part of a journal. That's where the journal is a collection of articles on a broad area. Now, this firm came with a particular idea of collections. What is a collection? It's trying to club related articles which are kind of based on the common topic or a theme. So it becomes easier to publish like this bunch of articles, this bunch of articles in a particular journal. So is this clear? Like from a simple perspective, if I want to summarize, I'm saying that there is a journal. A journal would have collections based on some topics, and inside each topic there would be an article. To give an example, it could be related to any scientific research that's happening around, maybe related to some environmental issues that are happening. So those are some of the topics related to that, and authors come and submit their findings or their learnings around that. Now, uh, when Sahaj came into picture, there were a couple of issues with respect to handling the submissions across these three systems. Now, what were the challenges with respect to that? Like inconsistent data. As earlier we saw, there are three submission systems. Every submission system is into an isolation, maintaining all that particular data. So when I say inconsistent data, it is in terms of the structure, the format, the terminologies being used across this system is different. The another problem, so basically the issue with that is that you are not able to come up with a unified view of how the submissions are working across different systems. Everyone would have the different terminology. That's the challenge. Everyone is submitting their own reports accordingly. Data is fragmented because the information about the submissions is distributed across different systems, which is creating a problem in coming up with uh, the key metrics, which would help to identify whether things are working fine or not. I'll talk about the key metrics that we use in this case in some time. So there was also poor data governance. In data engineering, you would have heard about data governance a lot and data lineage, all this kind of a concept. So in this case, there were no standardization in terms of data governance across these three systems. So which led to inconsistency in terms of quality, the correctness of the data, and the accuracy of the data. Delayed reporting, because the process to pull the reports from all of these submission systems was manual. So obviously, if some things goes wrong, there would be a delay in generating the report, or if there's some mistakes, it would be a rework, which would be a kind of a miss opportunities in terms of if it reaches the business in a in a later in the game, they would not be able to use that information, and directly it's a revenue loss. So yes, it has a lot of impact if you're not able to deliver the reports in time. So this causes inability to track the key metrics. Now, in this case, if you talk about, if you're able to relate to the earlier three contexts that I said, so we're not able to understand what is the volume of the submissions that are coming into picture, how the article pipeline works. Okay, like there's article pipeline when I say that whenever author goes and submits a particular uh, an article in the context of journal, so when they submit that, it has to undergo some stages with the pipeline. Like for example, it would go under something like a draft mode where you go and try to edit it as per the journal guidelines, then peer review, then editorial review, and then finally gets published. So it's a pipeline, right? So that is something we are not able to get correct metrics out of it. There's also concept of transfers, which I'll talk about. Yes, in general, it's very difficult to get the key metrics which would help the business to take decisions on it. So because of this, the challenges that business or the problems that businesses face is like difficulty in identifying the trends and gaps in terms of the submissions, inability to make informed business decisions because of delay in reports, inconsistency in data, which eventually causes like missed opportunities and revenue loss, and increased cost because every system is trying to do the same thing in a different way, and everyone is trying to solve the problem in a different way. So there was a cost incurred as well into it. Now the goal over here is to come up with an aggregated view of all these three submission data to help with reporting and analysis. Now the use cases that we came up with, the top three use cases that we came up with and try to get the insights on it are like the collections reporting. As I said earlier, like collections is something that they came up with an idea where they group articles based on a common theme. Now, the idea was like this would attract more authors. They would submit it. It would get accepted and eventually get published, which is like helping in building the revenue. This was a theory for collections, but is it really working? Right? You would want a feedback on that. Right? So that's the first use case where we talk about was the um, collections reporting. The another one was the article pipeline. The pipeline that I talked about, typically the worst case or an average case, the time taken for an article to be submitted to all the way to be published used to take months. Now, obviously, they would want to reduce this particular timeline, right? Because it's not a good experience for the author as well. This has a bunch of reasons because there are people involved, the peers who are involved, those are external senior authors who would review it. So there is a problem. Identifying that a particular article is stuck somewhere and kind of optimizing that life cycle, those inputs were not available. So that is something that we're building over here. The second thing. And third thing is transfers. To simply talk about transfers is like if I, as an author, submit a particular article for a journal, it might get rejected, but it might get accepted at some other journal. Now, from a retention perspective, I don't want like just because I rejected an author, they take their work and go to some other publisher and eventually gets published. We would want to retain them. So there were some also insights generated on this particular problem. Now, some the business key concerns or ask were like we would want to have this insight should be timeliness, freshness, and completeness. So everything should be up to the mark because they face these challenges. If you're sending a report which is like 2 days old report, it wouldn't help. They would want the reports to be kind of in a timeliness fashion. And obviously, they would want this on a daily basis, along with the support for in case if anything goes wrong. And along with that, there were other NFRs, which I'm sure, like from a data engineering world, you would have come across, like monitoring, alerting, observability, auditability, lineage, consistency, and accuracy. Any questions so far before I jump into the architecture that we came up with? So I don't have the exact number because this is happening across different systems. We usually, I would say that around uh, more than thousands or something submissions were happening every day. Yeah, because this is across the globe, right? What we're talking about. Uh, no, I did not get the details about how big a journal would be. But yeah, article would be like in terms of pages, right? Like maybe 10 pages, 15 pages. It's a research output. Yes, yes. PDF, like it would be something around, depending upon the details into it, like 10 MB or something like that. So it depends like what system they're using. It's not directly a PDF. It could be that you're going on their system and submitting it. They would have their own applications which would take in the input and then accordingly do it. So the problem is not about how you're submitting it. It's like the problem is about the feedback cycle. If I come and say that, oh, there's some changes that need to be done, or it's not something as per the standards of the journal, that's back and forth is creating a problem. So the question is like, how do we share the feedback in terms of the article pipelines, if I have to talk about? So this, whatever data we generate, the insights, what we generate, there are, so basically there are tools that would be using this information. So I'll talk about it when I'm showing the architecture diagram. Because from a data engineering perspective, there would be different roles who will take care of it, right? Like if you heard about the roles, like there are data engineers, data analysts, uh, and there are your stakeholders, right? Typically, a data analyst or a data scientist would be your consumers or would be the consumers of the data that you produce as a data engineer, right? So in that case, the visibility that how the data is being used in terms of from a business perspective, right? You would not have that visibility unless by some means you're able to talk to your stakeholders and get that feedback. But at least in this case, I did not have an opportunity to talk directly to the stakeholders and get a feedback. I'll show you. I'll show the diagram and show that how exactly this feedback and how this information is being. Obviously, I would not be able to show any kind of a real data or like code because of confidentiality with the solution of the client. But I'll show the architecture diagram, and from that, probably I would be able to help you to visualize how this information is being used. I think I'll okay. Um, okay. I know there are a lot of boxes and arrows out over here. To start with, let's talk about data product. So data product is some kind of a data set that is being produced uh, in order to provide some insights what exactly is happening. Right? That something would be consumable by different systems or downstream systems. So in this case, as I said earlier, there were three systems. One was Eclipse, one was Accelerate, and one is Nexus. So there were already two different teams which were taking care of Eclipse and Accelerate. Sahaj came into picture, which took up the responsibility for the Nexus data. And along with the Nexus data, aggregating all of those other data products as well. Okay. Now, uh, the sources in this case are my MS SQLs and Postgres databases. Majority of them are like Microsoft SQL databases, where every database had a journal information, and from that we had to extract. So before I dive into it, have you heard about the terms called as ETL? Uh, can anyone help me to understand what does it mean? Right? Okay. So ETL is something like extract, transform, load. I'm just going to rephrase it, where you extract data, there's some kind of a transformation that happens, and then you do perform a loading, right? Any idea what kind of a transformations we do in this case? Data cleanup, normalizations of data. Actually, it's more of denormalization, depending upon how you're constructing it. Sorry. Okay. Depending upon it's a structure or unstructured, you would have some kind of a transformations in place. For example, if it's unstructured, uh, you would be taking care of those things as well. You're right. By the way, this solution is related to data analytics with respect to only structured data. Okay. Have you come across the term called as ELT then? ELT. We talked about ETL, where you do extract, transform, load. Have you come across a term called as ELT? Okay. So just to set a quick context, ETL is something that has been around for a long time, uh, where literally even the data warehouses have been for a while, right? Where you would extract the data, transform it, and load it into it. Like I won't say exactly recently, but then also have the way then the point where the cloud world came into picture and started providing services like pay as per use and all. There's a concept of exact load transform came into picture because of the flexibility in providing storages, which is cheap as compared to your own on premises. Because earlier it used to be on premises. If you think all the way back to 1970s to 80s, you would go ahead and buy all those hardware and try to build your own warehouses, because at that time, big companies who were able to afford it, they were doing these things on premises. That's why I said, like, the moment cloud came into picture, things like every company who wanted to store data became a possible option because of the services like S3 and the compute power what we get through cloud was easily available. Now, in terms of extract, load, transfer, transform is where like you extract, load it first, and then perform the transformation. Okay, that's there are more, I would say, differences and similarities as well. But typically, in terms of extract, transform, load, you do not take all the data dump. You would go selectively choosing what data you want to pick. Like, for example, you won't directly take the entire dump of an OLTP and like, dump it. You might be selecting based on what you need, because obviously cost is incurred into it. But the moment it came to cloud world, oh, the cost is cheap for me. I can take the entire thing. Let me figure out later on. Uh, because in case in future, if I'm able to build better solutions, I don't want the problem where I lose the historical data. Okay. So this particular solution is kind of built on the same lines where we're doing the extract, load, transform. We're extracting the data, loading it into a system, and then transforming it. Any questions? Or did I confuse more in terms of ETL and ELT? Okay. So in this case, the source systems over here, is it visible or do I need to zoom in? Zoom in? Okay, I'm starting with those. Okay, if you take a look at this one, where we're talking about the Nexus submission system, these are the Microsoft SQL databases. The task is to extract the information from these particular databases and load it into a system, right? Now, you would want to have daily jobs which would extract this information. Now, there are different ways of doing it. Okay, there are different patterns of doing it. In this case, we uh, have this data extraction return using Apache Beam, where we are connecting to the database, taking the dump of the journals, that is the databases, converting into a Parquet file, and dumping into Google Cloud Storage as a first step. Any uh, any idea why Parquet files in this case? Or like, have you heard in data engineering Parquet file, right? Like, why do we compress everything into Parquet file? There are a bunch of options available. There is ORC, there is Avro, there is Parquet files, and also nowadays we are also talking about Delta Lake file formats and all. Uh, so one of the advantages with Parquet file, why we use it, it's a columnar file format, right? And the systems where it's being dumped, basically data warehouses. Now, in this case, the data warehouse is a Google BigQuery, which supports, which is compatible with, basically it's behind this thing's columnar file, columnar oriented only. So it's easier to ingest the Parquet files into it. Okay, but most of the times you'll come across in data engineering, based on the use cases, you would be going for columnar file formats. So it's interesting to compare like all these file formats. And based on use cases, you would change them as well. In terms of like when you're talking about lake houses and data lake solutions, you would hear about Delta Lake and file formats over there. So the task over here is like there would be periodical jobs which would be reading the databases and dumping that data into, basically compressing whatever information we get and compressing it as a Parquet files and loading it into the Google Cloud Storage, which is the staging area from where the next job is going to pick this up and load it into Google BigQuery. Now, once it is being loaded into Google BigQuery, here, whatever data we have, it's a pure raw format. There are different layers when it comes to data engineering. You first talk about a raw data format, then there is a staging area or intermediate area, and then you talk about the presenters models which are being exposed outside. Now, when I say raw format, it's like nothing cleanup, nothing. Whatever I got from the MySQL databases or MS SQL database in this case, I directly come and dump it. In this case, I'm not filtering out any kind of a thing. Versus in ETL, you would have an option like, let me, out of those 100 tables, let me select 25 tables. That's something I want to build analytics on. In this case, no, I'm right now taking every information. In this also, you could skip, but at least in our case, we're taking all the information. Now, once this information is available in BigQuery, then we are running some kind of a transformations. Now, this is some kind of a, I would say, when I say usable output rate, we're not running any kind of a business queries on this one. This is something like we're preparing it because I want to aggregate it with other and have my business queries on top of it. So in this case, the normal cleanup, the tests that we would run, right, in terms of whether in order to check the quality of the data, all those particular checks would be done over here. Now, this is something we are doing using DBT, the data build tool is doing the transformations over here. And Again, like you are re-ingesting or like you have different tables. Now, at the moment it's there in BigQuery, right? It's all about different types of tables out over there. These are just tables out over there now. This one single system in which you have tables. Okay. And dbt is the tool which would be helping you to perform the further uh, transformations. So before we get into the this thing, maybe what's dbt and Google BigQuery, do you have any questions in terms of the extract and load? So in this case, the transformations that are involved is like uh, you would have some bunch of tests that are being run over there. You could do, so in this case, typically we do the data data type conversions so that everything is inconsistent, because now in this case we have three different systems. There was inconsistent in terms of the data types as well. For example, the date formats, all those stuff. Again, like in case there are some data missing, which we could pre-populate it using some kind of information what we have, those kind of a things are done. So just kind of a preparing and putting into staging area so that it's ready to be consumed further. Schema checks, referential integrities, uh, null checks. In case if something that is something we can fix it ourselves, we could do that. But obviously, rather than we fixing ourselves, the best thing is like you go and talk to the source systems and ask them to populate it. But some things which you could derive it and it's not available at the source system, these things would happen over here, at least in this particular context. And the tech stack, what we're using over here is Apache Beam, using which we have written the data pipeline to extract the information from SQL servers, create a stage where you would compress it into Parquet files, and from there ingest it into Google BigQuery. Now, obviously, there would be other alternatives as well. Have you heard about any other alternatives than Apache Beam? I'm sure Apache Beam is not that famous as compared to its, uh, the parallel tools that what we have in data engineering. For example, Apache Spark is there, which is kind of quite widely used. So you would typically see the comparison between Apache Beam and Apache Spark, and there are others as well. Flink, all those things are all of the tools are there. So in this case, we went ahead with Apache Beam, and now in order to execute that, we have used the Google managed service that is Dataflow. So using Apache Beam plus Dataflow, and we have used Airflow as a orchestrator over here, which would take care of triggering the job every day where you're extracting information and pushing it to Google Cloud, and then accordingly initiating the next job about pushing it to Google BigQuery. Okay, let me keep it simple. So when you start your data engineering journey, right, there are lots of tools available in the market. There are a lot of different ways which you can perform the same operations, right? If you take a look at the data maturity model, right, for a particular company, or the data management model, I might mispronounce the full form over here. But basically, it talks about there are three stages where a company is starting with data. Second one is like using the data, and third one is like you're actually playing around or scaling with that data, right? Now, in this case, when you're starting with data, right, the role of an data engineer is kind of a generalist, right? Company doesn't have much practices out over there. Just they have a curiosity or they have a eagerness to go ahead and play around with data and make some, uh, uh, get some insights and try to make some different decisions. Now, in this case, now if you come up and say that, hey, let me pick up a tool where I need to do custom solutions to it, right? Now, in this case, the point is not about like how good tools you can make. It's all about like how well you can use tools to get better insights. The goal is to get insights for the company, correct? To solve a particular business problem using data. So in that case, typically we go with off-the-shelf tools that are available. And at times also you would prefer to go whatever is managed services available. Why? Because now probably at times we think, right, let me do something like self-hosting versus, managed service. In this case, you wouldn't want to spend your time in building an infrastructure where you would be running those tools over there, right? So the first thing is like go whatever this off the shelf. get a business value, and if you feel that, oh, this is something incurring a cost, then usually companies come back and try to do it. Okay, so that's why in this case, what we have done is went ahead with Apache Beam, directly used, though these were Python scripts, which is reading databases and pushing it to Google storage. In this case, we are not hosting our own infrastructure, but we're using Google Data Flow, which is compatible with using Apache Beam, and it would run on cloud using the managed service. Same thing with Airflow. Though Airflow is open source, we have used the managed service from Google, the Composer, in order to run the schedule jobs. Okay. Now, once the data is available over here, I talked about, so are we clear on extract and load? If any questions, feel free to ask. Okay. The next task over here is about transforming the information. Now, what exactly you need to transform into, right? So you can think about, in this case, let me take an example. If it's an e-commerce website, right? Usually there are lots of orders that are happening. Okay. Now, if I want to take a look at a customer's information, that how many orders they have placed in last months, what was the last recent order, or probably you want to give some, or in a particular area, even if I have to say that, right? In the area where are the hot, or which is the area which is like making lots of order, like a hot area, right? You would want to get those insights, because by directly taking a look at your transaction tables, you cannot derive this information. You cannot derive this information from transaction systems, right? You would want some systems which would read all of this information and give that to you. So these kind of like inputs which you get from business, where business would come and say that, hey, like earlier you said, like you want some graphs and all, right, or insights. You would want some kind of a problem what you're trying to solve, or like based on that problem, you come up like how can you get that information from the information, get that information from the data what you have. So transformation is a stage where the raw data what you have received, you have cleaned it up, you have done the filtering and like basic cleansing of the data. Now you're going to write your business queries, complex queries, to come up with new tables which would have that information. And that's what the data products what we talk about. So in this case, we do have one intermediate data product, but typically this is where the final data products would go. Now there are different modeling strategies over here. I'm not trying to get into that, but like if you have heard about, at least come across the words, right? Like star model, snowflake model, where you talk about dimensions and packs. So what is this? This is like the data what you have in OLTP is quite normalized, right? We did normalizations over there in our MySQL and I mean the OLTP systems so that they could perform well, right? Now, if you move this data to data warehouses, those are designed to solve different problems. Now, in this case, you would need to denormalize the data because they are those are like compute intensive. They can query faster as compared to your OLTPs. So in that case, typically you try to make it in a generic format where you could make some business queries. So that's a modeling part. So I would say that if you're on this particular journey, you need to understand how do you model your data where, how do you build data products? Okay, so keep this thing in mind. So writing those queries is something that we do over here in the transformation phase. Now, as I said earlier, it's a layer, right? Probably you would be creating intermediate views or intermediate tables in that case, where every day information gets populated to it, and then you're generating the final data products. So that is something we'll do in transformation. And in order to do that, in this case, we have used dbt. dbt is a tool that takes care of this thing. Now, where do you think these queries would be getting executed? Sorry? Yes. So dbt is just a means. I like to give a, uh, if you folks are from like have built some softwares earlier, like have you heard about Maven or Gradle tools, right? It's just similar to that. Like for example, your Maven or Gradle gets executed on some machine. In this case, dbt is similar kind of a tool, which would help you to execute the pipeline, right? On the designated machine. Now, in this case, as all your data is sitting on Google BigQuery, you would be instructing DBT to run specific set of stages, like read data from X table, create an intermediate table, then create another table, until you come to a point where it is ready to be consumed by your data analyst. Okay. Now here I'm talking about a different role. I, as a data engineer, I would be understanding how do I get the information into the system, do the extraction, do the loading part, to some extent, do my transformation part. But typically, this is where a kind of a gray area where the data analyst exactly would know that how what kind of a queries I need to run, or like how do I get those insights from the information that the data engineer has provided me. So that's a gray area. The reason I said a gray area, because if you are at the company working with, which is as a level one, right, from a data maturity model, where they are just starting with the data. So over there, that's why I said you would be behaving as a generalist. You would be expected to do the extraction part, probably take care of infrastructure as well, probably play a role of a data analyst as well, where you write the transformations and come up with these queries as well. And these queries generate the data product or the final data set, which is being used by the BI tools, like Power BI. You have something on Google as well, Looker, I believe. So those are the tools which integrate with this, and data analysts use that information to run their queries. The reports and the dashboards is something that the data analyst use that in the Power BI tools. But as a data engineering, the point where it ends is where you generate the data product or the data sets. So this is related to the question what you had earlier, right? So in this case, the Power BI tools comes into picture where they refer the information that you have generated, and on top of that, they would try to build these dashboards. Okay. So yeah, I was saying that the transformations in this case is something run by a DBT. Now, in this case, the DBT tool, I mean, the experience, what mine was like, it's kind of like well matured, and coming from a software engineering background where you talk about test and everything, it has that same ecosystem over there where you write tests. Now, in this case, there are normal tests where you test the query as well as you have data tests. So one thing I learned coming from software engineering to data engineering, you do have data tests as well. It's not something like you test a piece of a code, oh, it works fine. No, the data that is being generated, that is also needs to be tested. Okay, what do I mean by that? For example, you wanted to make some null checks, right? That function or that query is going to be run against every row in your raw data. And it would give you feedback that for this particular row, this is something null. And probably that's where you would want to take a choice where do you want to stop the pipeline and talk to your source systems, or you want to drop it. Typically, in this case, you wouldn't come in that situation because you already have your data contracts been defined between your producer and between your consumer. That's why you're adding a contract test over here. I'm expecting this information from you. So those kind of things are being well supported by your DBT. Okay. So in this case, the thing that I wanted to call out is like we would create an intermediate data products. Every team was expected to come with an intermediate data product. Here we are talking about we refer a common schema, right? Every submission system generates a common schema. We pick up this common schema and try to aggregate it. On top of that, we're going to build queries which would help to generate data sets that can help to build insights. Okay. So this particular part happens over here. Any questions so far? Okay. Maybe I'll move to the next slide, and maybe if in case if I have any questions, we can talk about it. So from a tech stack perspective, I did talk about it, but like just to recall, we used Apache Beam and the Google Data Flow as a runner. In this case, you could have different runners as well, like there's Fling, there's Samza, and there are other, like you could use also Apache Spark. Your Apache Beam is something like compatible with other these kind of query executors, not query executors, but this kind of like executors, or we call it runners in this particular context. Those are compatible with it. And in this case, we're using Dataflow, which is where we're using the Google's runner in order to execute this particular queries. We have used Airflow as an orchestrator, which is where we're using a managed service of Google Composer. We have done the entire thing in Python. The Apache Beam code is what we've used, Python programming language. It has compatibility with Java, Scala as well. Uh, in this case, we have used Python code. Do you think, is there any other alternative than this where you could perform the extraction? So in this case, we're not running the query against the data or the PDFs that are being generated. No, no. The insights, what we're generating, it's not what's being submitted by the author, but it's around the processes that are happening in the organization. That is something in case if you want to build some insights on what is being there inside your documents. No, no, I'm saying that. Okay, I'll rephrase my question. The things that what we did over here, right? Like the extraction and load phase, where in this case we have used Apache Beam as a tool where we are reading the information from MySQL database and dumping it somewhere, right? Have you come across any other tools which would help to do these things? Because this is a common thing in any problem statement when it comes to data engineering, right? Any kind of a managed service that you have come across? Have you heard about Stitch, Airbyte, or even like the cloud providers also give that? Okay, so what's happening over a period of time, right? As I said, like in data engineering, there are a lot of new tools and technologies that are coming up. Now, this is something where we ourselves are going and reading from a database and dumping it somewhere. But there are also some kind of a managed services also out over there. In fact, software solutions also available over there, because this is nothing but like you're connecting to one database and extracting and putting into the another data warehouse. So Google also has one of the managed service where you just tell, like, this is my databases, provide the connectivity. They would, behind the scenes, whatever we did over here, they will do it for you. Okay. It's just like going and configuring, oh, these are my databases, these are the tables, and this is the destination in BigQuery, just perform it. And in case if you could perform any kind of a in middle cleansing and all this stuff as well. Now, the things when the point when all of these things started, right? There's so many different types of databases, right? The first thing what data engineers would do is sit and write connectors or adapters for these particular databases. Agree? So the managed services that I'm talking about, right? Like Stitch, Pytran, all of these things are nothing but they come up and say that, hey, we have like maybe hundreds of connectors. You just come on a particular platform, pick up what database you have, the source. This is a particular pipeline you can build, and we would push it to your destination. So they are giving you a ready-made solution out over there. So that's one of the another alternative where you could use an managed service. Even the cloud providers like nowadays, Google and Amazon, they also provide, because in case if I do have the source system in the same cloud environment, like I'm using maybe DynamoDB or something from AWS, they would have some for functionality which would read the information and push it to a Redshift, which is a data warehouse, right? So these are the other alternatives what you could do. Obviously, now in this case for us, it was more of a pragmatic choice where we wanted to first, oh, let me pull up the information because some of the teams already tried out these things and they had their own constraints as well. Because, for example, if you're talking about any kind of a managed service like Airbyte or Fightrun, those need to be integrated with the current firm's. You need to take care of networking as well, right? You allow that services to be run or connected to this particular network and all those complexities are there, right? And we did not want to go to that directions, as well as it works fine with CDC. Have you heard about CDC? So CDC is something I think you guys should definitely check when you're talking about data engineering. It's more about a this would send even this would immediately send all the details, all the updates that are happening on a database side. It's kind of like streaming. Now, do we need streaming over here? No, we were like, oh, we are okay that we take a dump at the end of the day and push that information. So in this case, for us, it was a pragmatic choice for sure. There are definitely other alternatives. Like I said, CDC is there. I could use completely external third-party tools like Airbyte, Fivetran, which provides connectors to these particular databases. We did not use so we did not use directly the service from Google at that point because when we started this project, Google was they did not have a connector for the Microsoft SQL. So that's why we had to write our own connector in terms of uh, like using Python programming language and use Apache Beam to run that. Now, why Apache Beam? Why not directly write a simple Python program? Because in terms of scalability part, right, the Apache Beam framework gives you the flexibility to run things in parallel. It has that feature where it would, depending upon how much resources you can provide, it would run things in parallel. So I could like say that, oh, let me run all my 100 tables extractions in parallel by writing appropriate, using appropriate libraries from Apache Beam. And this is something you run directly on Google data flow. But obviously, they would give you a big fat bill because you are using a lot of resources over there, right? So it's a trade-off between like you pick up completely off the shelf or you want to take some time and write some kind of a, like customized solution to the problem that you're trying to solve. So that is something I just wanted to call out. So for transformations, in this case, we have used DBT. There is one more alternative to this one. I'm not able to recall that name, but it's a more of a proprietary tool again. This is more of an open source tool. Though they have the cloud services for DBT, but like we have used the open source open source in DBT over here. And as we were already into the Google ecosystem, we are using the Google BigQuery as a data warehouse. You remember I talked about the observability audit, the other NFRs that I talked about, lineage, data governance, and all the stuff, because those are important from a data engineering perspective as well. In terms of observability, we use the redata tool. Now, what this tool does it, this integrates well with the DBT. You can say that this is a library which would help you to detect some kind of an anomalies in your data that's flowing into your system. Okay, all of a sudden there is a spike in the number of rows that are going up, or there's a spike all of a sudden the rows going down, maybe a accidental deletion or something. So those kind of anomalies, right? DBT anyways internally gave you to flexibility to test the schema, right? Like, is this, you tell as a contract that I don't expect this column to be null. You would tell about what are the expected values in this. There's set of 4 to 5 things what you could do in DBT, but on top of that, you can also write your custom queries on top of it. Like what checks you want to do on particular column that needs to be run against each particular one. But in terms of like finding anomalies, Redata is the tool what we have used. But we faced a particular problem with this one because this used to give a lot of false positives as compared to the small data set what we had at that point. So later on, we had to move to Monte Carlo. This is more of a paid service. Now, this is more of a paid managed service by Monte Carlo. And this is something where it uses machine learning and other technologies to detect the anomalies in your data, what you have. So that's the cost for it. So anything goes wrong over here, we would be generating an alert into the system. In this case, we were using Slack as a notification system where we would send messages to the developers that these things have went wrong. And in that case, we were stopping the data pipelines. We would go back, fix it, If you see it's a genuine issue, you need to go back and fix it accordingly. So this is the reason why we do this is because you don't want any kind of a bad data to flow all the way down to your data warehouse, which would, like create problems later on because you would be building insights on those particular data, right? And if you're building insights on the wrong data, and if a business takes a decision on that, it's going to impact you. So in this case, the observability part comes into picture where you're stopping all of these things to happen, like flowing bad data in terms of a business context to reach to your data warehouses. Cool. The testing part. As I said earlier, the I would say the main crux of the majority of the test were the DBT test, where all the checks related to schema, null checks, unit checks, what values are there. We use the DBT test. Along with that, there were some customized tests as well, where for a particular column, based on the business context, we used to query to see how the information is flowing in. To give a random example, like probably you want to say that, this in this column, you're not expecting any date before I mean, like in the past, it should not be more than 90 days or something, right? So those kind of a checks where you're writing a custom query. I give a very simple example, but in our context, we had to write queries which were very specific to the business context. So those things you do have flexibility in terms of DBT where you could write your custom test, which is run again against each particular row that's coming into your system. We also had contract test for the inputs and outputs to cover, later on we also covered the staging areas. I did talk about staging area. Do you remember? Like the first stage, what we call it as a raw data. Then we have a staging area, which is kind of an intermediate data, which is generated by running some queries, right? And this particular thing is again, we run more queries in order to generate the final presenter models, what we call, or the data product, what we call, or the final data sets. So in this case, the input is something what I'm talking about, the raw data, right? We do have contract. So in software engineering world, if you have come across API, in an API, we talk about a contract test, right? Where you expect, if I'm like, for example, I'm a Google UPI API developer, right? I would be telling my consumers that this is the API, this is the request that you need to send, these are the input parameters that you need to send, and this is the output you would get. Based on that contract, you will go ahead and build your systems, right? And if there's a particular change, you would go and update your contracts, and then you would proceed. On the same lines, the same thing is kind of a concept applied over here when you talk about contract test, where it's a kind of a pre-negotiated, like what data your source systems are going to send. You know the schema, you know that what the schema of your source tables are, you know what data they would be sending. So you are kind of setting a contract over there, like not nullability checks, referential checks, all those things you would do from a contract perspective. Same thing you would do it for the output as well, which is the presenter models. That's something that you share it with your data analysts, which connected to your Power BI tools, or probably that is being used in order to ingest to your machine learning models and all this stuff, right? So you also have some contracts on output where you return some tests in order to expect what data needs to be generated over there, right? So those kind of tests what we return, and also we had later on added for the intermediate staging layers as well, so that you get an early feedback. You don't need to wait all the way that something goes wrong at your output table. Whichever the important intermediate staging area at that stage we had done. So as I keep saying, staging area, right? The thing here is that as everything is happening over here in SQL, right? You folks all knows like what is a temporary table in SQL, right? You know what a view is, right? So why do we do that? Because you're trying to run some queries, have an intermediate output, so that you can use it further for other things, right? If there's a lot of complex queries that you're using, you're generating some intermediate outputs, and then you're consuming that. There are obviously some challenges in terms of or restrictions in terms of views, your temporary tables as well. That's where the CTE thing was introduced, in terms of SQL as a later feature. And there is a difference between. So CT is also something like the data is there sitting until your queries run. Those are like intermediate things. Now, the output of those CT is something that you want to push it as a table or a view. That's something what I'm talking about, a staging area, where a complex query is broken down into multiple queries. And the intermediate output of those is something what you store it somewhere, maybe as a table, maybe as a view, right? Or maybe it could be in memory. So that is something what typically when I'm pushing it to a particular table, that is something I call it a staging area because it's persisted. I'm going to run some tests around that as well so that I get early feedback. Now, local testing as well. This entire thing is running on cloud, right? We went to cloud because we cannot have these things running on the local systems. You could, but like the actual test is where you're able to run everything against the data, right? Running it locally means like taking a dump of the actual production data or the raw data on your system and trying to run it and then see a feedback. So in our case, we had separate schemas for each developers where they would run those, which means like the raw data, you could use the raw data, which is there in your probably a dev environment, right? That's common for all. And that is something being transferred to the schemas, developer schemas, right? Because we don't want to change the things that are there in the QA environment or something, right? So we would take it, run those outputs and generate, I mean, run those DBT queries and generate those output on a developer schema, right? So obviously, there's a cost to it because you're already paying for your QA environment, your production environments, and obviously you would have to pay for your developers, whatever resources that they use from compute as well as from various standpoint. That's why there are times like best practices, what we talk about, like how do you use Google BigQuery? Because you don't do Slick Star because it's going to use a lot of resources and then it will return you the data, but obviously behind it's going to charge you for that. Oh, I returned you like 100 GB of data in this Slick query, but yes, you're going to pay for it. So there are some practices or something that you would want to avoid when you're working with these kind of tools. So yeah, for testing, we had the point over here is that for testing, we had separate schemas on Google BigQuery where we would run our code against the feature branch. So feature branch would run directly pointing to Google BigQuery using the raw data from a QA environment or a dev environment, and we would test out. We would test these things. Now, how would you test it, right? How would you know that the insights that are being generated, those are correct or not? Let's say that you are working on one particular enhancement, right? And you made a particular change, things work fine. Your all tests ran through the DBT test, what we talked about earlier. This went through, those went through. But how do you know that the insights that are being generated, those are correct or not on your feature branch? What's the first thing that you would want to check? You're running against the same data, by the way. You try to compare what's there on QA, right? So here you're trying to talk about comparison of tables across different schemas. So what I'm saying is that I do have a specific environment where raw data is coming in. I run my data engineering pipeline and I do generate the data products. This is something already being consumed by my business. As a developer come in, I want to work on a particular feature where I'm enhancing some things. Now, did I break something or no? I could do that by like I run again this the on my feature branch. I'll run the entire data engineering pipeline, and the insights that I get, I can compare it with the QA environment or a production environment. If there is a mismatch in the values or the insights that are being generated, oh, you messed up something badly. But it's a costly operation because you're comparing against each and every row, right? So in our case, we did have this automated regression test, but it was not part of the CI pipeline. This was more of a like on-demand thing, or like when we are at the end of the sprint, we would run it. But yes, cautiously, we did not run it as a part of the CI pipeline because it would charge us a lot from the cloud perspective. Cool. Yeah, these were the things that I wanted to share from the solution perspective. If I have to quickly share some of the other kind of insights, which I was expecting as a question. So earlier we had a question like about the amount of data that we were dealing with, right? In this case. So so if I go back to this particular diagram, so the overall, the presentation tables that what we had, those were around 427 million records. Rows, when I'm saying, is like the final presentation models what we have, right, across aggregated, Eclipse, these particular data products. So this is something like 427 million records, which is approximately around 206 GB. Not that, I would say a lot of data, but yes, that was the size. Our raw data in that case, only for the Nexus part, it was around 73 GB, around 263 million records. So this is where we were okay to use Apache Beam, write it, and then because the amount of data that what we're loading every time. So initially, by the way, like just to tell you pragmatic approach what we took, the first time when we started with this one, it was like pick it up, delete all, insert again, because that was less amount of data. Because the first thing what we wanted to do is like use the data, generate some insights, and try and validate with the business that is it something what you're looking for. So that was the first pragmatic approach what we took, which later on then we came up with like, oh, it should not be like that. We should not like once this we realized that the things that what output we're looking, this looks correct. Let's go back and do append only. And get only the snapshots every day, what data is being added. So those are some of the pragmatic choice what we have done. Cool. Yeah. There were other practices that we talk about as like data catalogs and all you would hear in data engineering. So in this case, uh, we did start using the data catalog from Google, but eventually that didn't work out well because adapter like using so from a tech perspective, the data analysts and all they would use that, but like eventually having that practice across the company did not work, so they had to fall back into using something else. But yes, like when you're talking about data engineering project, you do talk about data governance, like who would access your information. You would want to have a lot of restrictions around that. You would also have data lineages. In this case, dbt is a tool that used to build the data lineages for us and we used to publish it. So what do I mean by data lineage is that you can think about, it's kind of if I have an insights, it would tell you which all tables did it use to generate that data. So you can all the way traverse back all the way to the source table. So it's like XYZ table being used, then I create an intermediate A table, and then finally output. So it would tell you that, oh, this came from A came from XYZ. So that is what we talk about data lineage, and this is important in terms of data engineering, where you would want to know. Now I'm talking simple ABC, right? In this case, there are lots of there are so many tables you can't remember them. So you would want a view where you would want to understand the information that I'm looking in my insights. It's coming from where. Now in this case, we have all the raw dump in our Google BigQuery. It's easier to tell these are the tables, and people can take a look and make a sense out of it. Cool. I think that's it. What I had. In case if you have any other questions, I can take that up as well. Yes. 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 For every row, you would do that. It's costly. That's what data tests are for. Because in this case, you cannot afford any wrong data to be went ahead, right? So that's not a test like what you write for your code. It's about a data test. The data that is flowing in, you're making sure it's correct or not. Yes, there is a flexibility in DBT where you could see that select, for example, if there are, you're taking a look over here, right? Like if I had these data products like Eclipse, Accelerate, and Nexus, I can say that, oh, Nexus data product, which is an intermediate state, this is the model, right? I can say that run test only till this model. So it would run test all the way from whatever we have over here. It's not pointed. Like earlier to this one. It's going to ignore the above ones. But if I'm going to run against the entire project, it's going to run it for all the data what we have. So you do have a flexibility where you can say that run this test only to test this particular model. Because if you're changing your code for a specific model, you don't want to run every time, right? Obviously, it would run as a part of your CI pipeline. But like if you're doing a development, you would want to run the test, select a test only. So this is how you shortlist or like cut down test when it comes to TBT. Any other questions? Well, I hope this was helpful. I was able to share some of my learnings, what I had through my data engineering journey. Uh, I did had different experiences as well, like trying with this one, then learning, oh, this is not the right way of starting with data engineering. You can say that I have my own mistakes, and which I personally like to share with whoever starting data engineering journey. Right? Oh, probably you would want to avoid this and focus on these particular areas. So that is something I'll be happy to share with you folks, which we can do it offline as well. But yes, just wanted to share from a project perspective that what we work, and this is it.